Alright, finding the angles given sine or cosine problems. First of all, this is not problem number 17 this year, so we'll cross that off. Now, sometimes the problem starts off already set up for us, sine and cosine already by themselves. The first example here, not quite, just a little bit of algebra to get the cosine by itself. In this particular case, divide both sides by 2. Cosine is equal to a half, is this problem. Now, cosine is the x value, sine is the y value, so at this point I need to draw an angle that has an x value of a half. Because it's positive, x values are positive to the right, so I needed to make an angle to the right side that is a half. Now, a half is approximately there since this is a unit circle, so if I made an angle, dropped my triangle down, the x value, which is this guy right here, is a length of 1/2. And that's what's given to me. Now, because I could draw 2, I'll do that now. This triangle also has an x value of a half. These two are the possible locations for my solutions. Now, because that's the 1/2, I know that the angle opposite the 1/2, this angle here, is 30 degrees, which is also this angle. If that angle is 30 degrees and I've made right triangles, then the reference angle is 60. And the reference angle is asked of you, so that 60 degrees is required. That's the reference angle. Now, because that's a 60, the denominator of our angle is a 3. Both are 3's. Starting from 0, working in the counterclockwise direction, the first one we come to is pi over 3. Straight left, just as a reference point, we know is pi. That's 180 degrees. I like to make it 3 over 3, or 4 over 4, 6 over 6, whatever we're doing, 3 over 3 in this case, because that's 1 pi. So I can almost count it. 1/3, 2/3, 3/3, 4/3, 5/3, 6/3 if I went all the way around. The circumference of this circle is 2 pi. 6 over 3 is 2, so it's just another way to reference it. So this guy that we passed earlier was 5/3. So these would be our normal two solutions of cosine is equal to a half. However, we have a domain restriction that says find the answers that are greater than pi but less than 2 pi, meaning from pi to 2 pi, find the answers that take place in there. So, not here, which means 5 pi over 3 is our only solution to this problem in that given domain restriction. Okay, problem number 2. Cosine is equal to -1. This happens to not be a special right triangle because the only place the y value is -1 on a unit circle is straight down, right there. That is the only place that has a y value of -1. So that angle is the solution to this problem. That angle, which is halfway between pi and 2 pi, if you were going in a counterclockwise, is 1.5 pi. I don't want you to write 1.5 pi. Please make that 3 over 2 pi. Oh, God. 3 over 2 pi. Sorry about that. 3 over 2. Check the domain restriction. It says find the answers from 0 to 2 pi. So it is good. We keep it. C says sine is negative. Square root of 2 over 2. Now sine is y values, and y values are negative down. So our angles are going to take place in quadrants 3 and 4. We make our triangle straight up to the x-axis. So from there we go straight up. The square root of 2 over 2 happens to be the y value, this up and down. That is root 2 over 2, as is that guy, root 2 over 2, negative. Because it's the square root of 2 over 2, the reference angle is 45 degrees. 45 degrees cuts pi into fourths. So, starting from 0, here is 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, and finally 8/4, which is 2 pi. So 5/4 and 7/4 were these two locations. We check our domain restriction, which says find the answers that are between 0 and 3 over 2 pi. Here's 0, and here is 3 over 2 pi. So from here to here, stop, which means we don't find any answers in quadrant 4. So 5 pi over 4 is our only solution. Cosine, negative, that is to the left. So we need to make two angles that are to the left, here and here, that have x values, which is this guy right here, of square root of 3 over 2. So this shaded area right here is square root of 3 over 2. That's what's given to you in the problem. If that's the square root of 3 over 2, the angle opposite it, this angle here, is the 60 degrees. And if that's 60 degrees, then this reference angle in here is 30 degrees. The reference angle helps you figure out the denominator of your angle. A 30-degree reference angle is in terms of sixths. Straight left is pi, which we know is 6 over 6. So the one right before it is 5 over 6, and the one right after it is 7 pi over 6. Check our domain restriction, which limits us to quadrants 1, 2, and 3, which doesn't eliminate any of our answers. So 5 pi over 6 and 7 pi over 6 will remain. Okay, I'm going to show problem number 2. Press pause, copy that down. You will notice a couple of algebraic steps here that might be challenging. I'll just kind of give you the heads up here. On this particular problem, you'll need to add the square root of 3 to both sides, which gives you 2 square root of 3, commonly missed. Then divide by 4, and then simplify that, and hopefully you notice that this problem is just cosine is root 3 over 2. Alright, copy that down, press pause, I'll show you the answer. That is problem number 2. And here is problem number 3. Press pause, copy that down. And here's the solution to problem number 3.